All right, sure, thank you. So I think I'm having issues with my audio, so I'll just remove it and use the PC audio. Hello, everyone. Trust you are good morning, good afternoon, good evening, wherever you're joining from. Thank you for joining this webinar, and it's a pleasure having you. So this webinar is about a series, a monthly webinar series organized by data engineering community. So we are going to be having this webinar every month, and to kickstart this, we are starting this January with this interesting and very important topic, which is data pipeline design and best practices, presented by myself. So for those that may be joining us for the first time, I'll just do a quick introduction about myself. So my name is Najeeb Sulaiman, and I'm a data engineer. Forget about every other thing else. That's what most important now. So jokes apart, so I'm a data engineer, and I currently work with JLR UK. I'm also the founder of data engineering community, which means I'm the number one. I'm your number one servant. So, and the whole vision about data engineering community is to have a community where data engineers across all levels of experience can come together to interact and share ideas and have to gain knowledge, like by webinars and all the other stuff like this. Yeah, and the whole intention is to encourage beginners to be able to venture into data engineering. And that's because data engineering as a career, unlike some other IT aspects, seems not to have enough visibility. It's getting better now, actually, but I mean, we can do more. So it's about helping people to get visibility into data engineering, what it is, what it's all about, what the data engineers do, and having that environment where we can help each other grow, regardless of the level we are. So enough introduction, and if you are joining us for the first time, you are very much welcome, and we're happy to have you among us. So without further ado, I'll just dive right into the main topic discussion of the day. So as I've known, the discussion is about data pipeline design and best practices. This is the art of data engineering. I mean, most of the things we'll be doing as a data engineer revolves around building data pipelines, building infrastructures that support and aid business data-driven decision making. So, which is why it's very important. But how do you not know how to design data pipeline and understand the best practices without understanding what a data pipeline is? Because I understand there are many beginners joining us, even from the registration form that was filled, more than 70% are beginners. Some are even aspiring data engineering. So I'll try and make sure this is as much beginner friendly as it can, so that we carry everybody along and not just the experienced data engineers are able to gain something from this. So I'll make sure I'm breaking this down in bits so that we all gain from this valuable topic. So a data pipeline simply refers to the integrated set of processes, tools, and infrastructure set up to automate the flow of data from various sources to its end destination. So forget about the English. In simple time, it simply means data pipeline is a means of moving data from one point to another, usually from source to destination. That's what data pipeline means in a layman term. So, and I'll give you an analogy to kind of drive this home so that you can understand it if I just hearing the word for the first time. So if you have a very humble background, right, you must have experienced something like you need water. So I'll use water to kind of give this analogy because water is life and now data is life as well. So they kind of go hand in hand. So let's in the olden days, or let's say a few years back, where there is no enough infrastructure in some developing countries and underdeveloped countries, whereby they have sources of water. Sources of water can be well, river, rain, and any other source of water. But the challenge is they need this water. They need water to, to bath, to wash clothes, wash plates, clean the house, and a lot of other things. Water is very important. It's a basic of life, basic need of life. So, however, there are no infrastructure in place to kind of get this water into their home and to make use of the water to do the several cause and every other thing they want to use the water for. So what happens then is people tend to go to the river, to the well, or to any other source of water they can. Then they go with buckets on their heads to fetch the water and bring it to the house. Then they have a storage, like maybe a storage, a reservoir in the house where they store the water in it, and they go to that storage whenever they need water in the house. So it means they go multiple times to the river or to the well to fetch the water, dump it into the storage, then they can make use of it for any other things they want to make use of it for. So however, as innovation comes in, as technology comes in, as things advanced, infrastructures begin to comes in place whereby we can channel water from any source to its destination, and then you can make use of that water for anything you want to make use of it, make use of that water for. So that's when pipe comes in, and pipeline in this sense, think of pipeline in this sense, pipe for water. Now we come back to data. So this pipe when pipe were developed and other infrastructure were put in place. So it means rather than people going to the river, going to the well, or any other data source, or any other water sources, they can actually run infrastructure that can channel that water from wherever that water is into their home, and then they can make use of that water with ease, without the needs of ASU to go into the source and all other things, and they can be more productive, use that time for something else, rather than worry about getting water into their house. So this is the basic analogy of a data pipeline. Data pipeline does the same. You have your data scattered everywhere, different sources, different formats, but this data needs to be converted to something to make use of it. You need that data in the first place from wherever source it is into a destination where it can be useful for your need. So that's this. I believe this we'll be able to correlate this together now. So data pipeline is the infrastructure put in place, like your water pipeline is the infrastructure put in place to get data from wherever data is sitting at. It can be in different sources, can be in a database, in a flat file, API, it can be in any source, and it can be in any format, structured, unstructured, semi-structured. What is most important is your data pipeline does bring that data from different sources into a destination where it can now be used for consumption. It can be for analytics, it can be for machine learning, it can be for anything. It can even be just for storage, maybe for historical storage or anything. But that's what the data pipeline does. So it means for any data-driven organization or for any data-driven ambition, the art of it is data pipeline, because in the first place, you cannot build anything meaningful without having an infrastructure in place to kind of get this data into a place whereby you can use it for any other consumption you may need it for. And that is why data engineering is a growing career field. It's growing day by day, because as technology grows, data engineering is growing because we generate more data. We need infrastructure to be in place to manage this data and be able to make this data useful. Gen AI, you can imagine generative AI, which is gaining momentum since last year up to now and continue to gain momentum. It's even said to be like the biggest innovation of man ever, that is going to be bigger than internet itself. So, and what's the art of this Gen AI? It's data. And that data, what is powering that data? Infrastructure. So that is data pipeline in layman term. Okay, I hope you understand. So I'll just move on from there so that I don't flog it too much. So now, why is data pipeline important? We understand data pipeline. From my explanation of data pipeline, you must have picked some importance of it, why data pipeline is important. But not just pipeline now. Why is an efficient data pipeline important? Why do you need to build a robust data pipeline? Aside from the fact that it's helpful because it helps you get your data to wherever you need it, why do you even need a scalable, efficient data pipeline? These are important concepts you need to understand before you can even dive into designing a pipeline or even learning about the best practices of pipeline. These are the fundamentals. Now, I'm going to explain why you need a robust, scalable data pipeline in these are the 5 V's of big data. So these are the 5 V's of big data. If you're not aware about it, I will explain it in detail so that you can understand and map it to why it is important to have a scalable and robust pipeline in place. Now, volume, velocity, variety, veracity, and value. These are the 5 V's of data. So these are the characteristics of big data. You can classify a big data, or you can classify a data as big data if the data possesses these 5 characteristics. Now, volume. Why do you need a data pipeline in place in terms of volume? So volume is the amount of data qualified as big data. So it means as technology grows, as human beings, we evolve, we innovate to make things happen. We continue to generate data every second, every minute, every hour, every day. It means we continue to have growth in data. So it's not static. The data that has been generated in the last 2 years, according to Google report, we have generated more than 90% of data in the last 2 years than what we have generated in the entire human history. So it means if you have 100% of data we've generated in the entire human history, in the last 2 years alone, we have generated 90% of that data, and it continues to grow like that. So imagine in 2025, in 2030, in 2040, the volume of data will be, that will be generated by human beings or by any other system we have put in place. So it means in terms of volume, a data pipeline that is robust needs to be in place to be able to handle this massive volume in growth in volume. So it's insane. In fact, I even put something in the community just this afternoon about how data is growing. Data is growing drastically and is not going to reduce, it's not going to decrease, it will keep growing. So that infrastructure needs to be in place to be able to manage this large scale of data. Now, in terms of velocity, so the speed at which this data is being generated, and this is kind of directly proportional to the volume. The speed at which we generate data these days, it's alarming because we generate data in microseconds. Imagine sensor data. Sensor data are not even in seconds now. It's even different from data that you generate in seconds or minutes or hours. Sensor data are generated in micro milliseconds, which means in a second itself, we've generated thousands of data from sensors. So you can imagine the frequency of data. So to handle all these things, there needs to be data pipeline in place to be able to handle this frequency of data. Variety simply means the diversity that exists in the types of data. So diversity is not only existing in human beings, right? That we have different people from different continents. You have Asian, African, American, European. In Africa alone, we have Nigerian, Ghanaian. In Nigeria alone, we have Igbo, Hausa, Yoruba. You can continue to break it down. So diversity also exists in data as well. We are not just generating one single format of single type of data. We are generating different formats, different types of data, structured, semi-structured, unstructured, in different form, in different formats. So there needs to be an infrastructure that is able to translate this kind of data, ingest this kind of data, and make it consumable, right? So these are importance of data pipeline, robust data pipeline. In terms of veracity, calculate quality and accuracy, it's not just about making data available now. Yes, you can use any method, any tools you like to get your data from point A to point B, but how quality is that data? How accurate is the data? And if care is not taken, you can be misleading rather than giving insights on data. So there needs to be a robust pipeline, scalable and efficient pipeline in place to be able to give quality and accurate data. So the value the data provides. So it's not about pipeline alone. Is the pipeline giving value? Is the pipeline usable? Is the pipeline helping or solving any problem? Because in the first place, there needs to be a solution to the problem. So if the pipeline is not solving any problem, then why do you need the pipeline in the first place? So pipeline are existing in order to solve problems, and in order to solve data problem in terms of putting infrastructure in place to support data consumption. So these are the 5 V's of big data. And these are the 5 reasons that I've given you why data pipeline is important. So volume, velocity, variety, veracity, value. These 5 V's of data makes it important for us to have not just a pipeline, but a scalable and robust pipeline in place. Moving on. So let's understand the components of data pipeline now. So I've been talking about pipeline, why is it important? So what are even the backbone of data pipeline? What makes up a data pipeline? We need to understand what pipeline is, the architecture in a high level. In low level now, what does it even consist of? What are the components of a data pipeline? So the first component of a data pipeline is data sources. What is the pipeline serving if there is no data source? If there is no source, so where are you going to get your data from? So data sources are like the fundamentals of the data pipeline. There needs to be a data source. Your data must be coming from somewhere. So these are the original repository where the data resides before it's being processed. So it can be in anywhere. It can be in form of API. It can be in form of sensor data. It can be sitting in a transactional database. It can be sitting on a flat file in terms of Excel, CSV, Notepad, anything. So these are the original source, original repository where your data are residing before you process them or before you ingest them into your pipeline. So in data source, you can think of data source now in terms of water. The analogy I gave about water, you can think of your data source as your river, your well, or wherever that's your water might be coming from. So these are data sources. Now, data ingestion. So data ingestion is like the initial step of capturing raw data and introducing it into the data pipeline. So you have a data source. The data source needs to be ingested, needs to be extracted into your system so that you can further process it and make it available. So if you have a humble enough background whereby you have water pumps, so you know if you have seen where, or if you have an idea about how boreholes are being built, if you have a humble background enough, so you have a water pump that is being put into a well, for example, or dug into you dug the ground till you get to water. But I'll give an analogy of a well whereby you put a water pump inside the well. So the well itself is the water source, but that water in the well needs to be used in the house. But there is something that needs to be an infrastructure put in place to kind of pull that water from the well, then transfer it to wherever you need it. So data ingestion is the process of pulling that data from wherever source it is into your own system. I hope that's clear. Now, moving forward, data processing. So once data is ingested, it often needs to be transformed to be useful. Data in its raw form is usually not useful. Most of the time, there needs to be processing, there needs to be transformation going on for that data to be useful. So this part of data pipeline is where you ingest data into your, after you ingest data into your pipeline, you transform it. It can be in form of cleaning, can be in form of schema, validation, anything. So processing is like a transformation layer whereby you transform your data, you make it more usable. You at this point also, you can also apply business logic. Maybe your data is in raw form, you need to apply business logic to perform some calculation, to derive from metrics before you even hand it over to an analytics developer or whoever that wants to use the data. So at this layer, that's where you do the transformation. So you can see this layer as, after pulling water from your well, you need to put some filter to filter out the dirt in it so that you have clean water and use clean and usable water. So that's the essence of data processing in the pipeline. So we have data storage. This data needs to be stored somewhere. After you pull it from your source, you ingest it, transfer. It needs to be stored somewhere so that it can be continuously available for use. So this is the storage. It can be in form of a data warehouse, it can be a data lake, depending on your architecture, depending on your use case. Just know that the data storage is where you store your data after pulling it from your data source and performing any other processes you want to perform on it. So data consumption layer now. So this refers to the end use of the data process of the process data. So this is the end use. So you store the data. So the data consumption layer is like your reporting layer. So maybe you want to connect to your data from Power BI, from Looker Studio, from Tableau, and you want to start deriving insights that will be usable by the management and the organization. All right. So this layer handles data consumption. So orchestration now. So orchestration, as data moves through various stages, there needs to be a coordination of tasks, error handling, retries, and logging. So you have different parts, different processes, different bits that exist in your pipeline. So there needs to be that tool that kind of bring everything together, kind of make everything work together to deliver your data and to undo errors, retries, login, so that you can know when pipeline runs, what happens in your pipeline, and get visibility in your pipeline. So this components handles that, and usually that's where you talk about tools like Airflow, tools like Prefect, Darkstar. So these are orchestrations to kind of schedule your pipeline, monitor your pipeline, arrange your pipeline, build dependencies in your pipeline. So that's the work of orchestration tools. Now, the last component is data management and governance. So, and this requires practices, processes, and tools put in place to ensure your data is compliant. Please mute yourself.
Good evening. Sorry for joining late. This is Samuel.
Okay. Please mute your mic. Just join it. Wherever you join, just continue. It's fine. So, these requiring practices, processes, and every tools put in place. So data management and data governance is very important as well, and needs to be added as part of a component of a data pipeline, because you don't want to build a pipeline that is not compliant. If you are building a pipeline you need to understand the compliance in terms of at team level, at organization level, at industry level, at country level, at continent level. There are different regulations and compliance. So you don't want to build a pipeline whereby you are ingesting PII information. PII information is like personal identifiable, personal identity. Sorry, I've forgotten. So PII is just like personal information, personal data about someone. So you don't want to ingest that kind of data if the compliance in terms of where you are working, the environment you are working does not support it. You don't want to ingest into your pipeline. So you need to build rules in your pipeline to kind of avoid that. You need to put practices, data management in terms of data monitoring, data logging, building catalogs, and all. So this component is also part of data pipeline. So you need to that needs to be put in place for a robust pipeline. So I hope this is clear. So after understanding this, then we move forward to the next important thing in terms of designing a data pipeline. So this is a simple diagram that kind of illustrates two major types of data pipeline in terms of processes. So we have ETL and ALT. So these are the most common types of data pipeline in terms of processes. So, and in basic term, what it means is that since the data pipeline is pulling data from source and loading to destination, like moving data from one point to another, that's like the layman term. ETL simply means extract, transform, and load. So it means extract the data from wherever the source is or whatever sources you have, transform the data before you now load it into its destination. So this extract, transform, load is what is ETL. What ALT simply means extract, load, and transform. It means you extract the data from wherever sources it is, you load it directly into the destination before you now transform the data. So now ETL is like the traditional mode of building data pipeline, whereby you have to transform your data before you load it into the destination. And this is usually applicable whereby resources is a constraint in terms of storage, in terms of compute. You want to be able to have only what you need in your destination. You don't want to load everything to your destination before you start refining your destination, right? So it has trade-off as well. The trade-off is you don't have raw data available. For example, if you want to be a machine learning model or something that you need raw data, it may not be available in your destination because you have already transformed the data before you load it into the destination. So it has trade-off. That is why you need to understand the fundamentals to be able to know, okay, fine. In terms of my use case, what do I need to do? What is required of me in terms of building this pipeline? Whereby for ELT, it means you extract the data, whatever format, whatever size it is, regardless, you extract it, then you load it into the destination. So remember, the destination can be anything, the source can be anything. I've given an example of sources. It can be from database to a data warehouse. It can be from an API to a data warehouse. It can be database to database migration. It can be anything. So source is wherever your data is, then destination is wherever you are loading your data to. So you extract it, load it the way it is in raw form before you now begin to transform. So this is like the modern way of data engineering. They are both modern, regardless of, it depends on what you want to perform. But this ETL evolved to ALT. So it means you have raw data in your destination and you can build machine learning model on it. If you have enough resources, it means you don't have much concern in terms of resources. You have enough compute, you have enough storage. You can load as much as you want. Then you can transform to derive whatever you want to derive. So these are the two processes you need to bear in mind when designing a data pipeline. Are you designing an ETL pipeline or an ALT pipeline? There is also EL, which is just you extract, you load, and you forget about it. No transformation that is needed. So, but I'll just leave it at this. So moving on. So this is another graphical representation so that we can drive your points and make sure we understand what we are discussing. So this take it a little bit higher in terms of now you can see from the left side, you can see streams and batches, which means the two types of data pipeline we have. We have stream pipeline, we have batch pipeline. So, and I will explain the two. So for batch simply means you load data over a period of time. You don't over a period of time. Yeah, it's time ranged data. So for example, you want to you build a pipeline that ingests monthly data. So monthly data means from the first of the month to the end of the month. So that is a batch pipeline because it goes back in time to ingest a time ranged data, right? So, or we want to do daily reporting and your pipeline simply needs to ingest 1 day data. So you are ingesting yesterday data or day before yesterday data, for example. So that's a batch pipeline. Stream pipeline, on the other hand, means near real-time pipeline. So it means as the data comes, you ingest. You don't necessarily have to. You don't go back to say I want to ingest 1 month's data, 1 year. So as the data comes, you ingest. So it is near real-time data pipeline. So and the difference between the two is in the definition. One, you ingest in handful, the other you ingest in stream. So let me also put an example to make sure you understand. So I will also use water again. So let's say from the different sources of water I've mentioned. So let's say you have rainwater now. So you know rainwater because rainwater, you don't know when it's exactly when it's going to rain, although there are technology in place now to know, okay, fine, it's going to rain tomorrow. You may essentially know it will rain tomorrow. You may even know it will rain next hour, but it may not rain. God decides that. But you can still predict. But essentially, stream pipelines in terms of water means rainwater. You just want to capture the water. So if you have a humble background, as I've been saying, because I know some people might not be able to get this analogy if you have not experienced it before. So you know there's in some houses, in Nigeria, for example, you have at the tail of the roof, you have build your own like something to kind of trap rainwater. Then you now channel the water into maybe like a storage so that you can make use of that rainwater to do ask calls and every other thing. So in that sense, it means that infrastructure you've put in place is to capture the water, to kind of the data source, the water source now is the rainwater, capture it, then move it into a storage, which is your warehouse now in terms of data. Then you can now go to that warehouse, then which is a storage in terms of water, to get the water into the house and use it for whatever you need to use it for. So it means as the rain is falling, the water is getting into that infrastructure, immediately going into the storage. You don't necessarily have the luxury of that decision to kind of say, I want to get rainwater of last month. You can't get it back. I don't know if anybody can get it on this call. You can tell us how to get it. Maybe you want to say, okay, fine, rain fell yesterday. Then I want to now build my infrastructure to now capture that rain that fell yesterday so I can now use it in the house today. No, that may not necessarily be able to, you may not necessarily be able to do that, but you can always build a stream pipeline in terms of data now to capture the data as it's happening. So as the rain is falling, you are capturing the rain, then directing it to your storage, then you can make use of it to work for whatever you want to do. So that is kind of stream in terms of data. You are capturing it as it's happening. So it might be from IoT devices, it might be from API, it might be from anywhere, any source, but just know that the main distinction is that you are capturing it as it is near real time, as it's happening, you are getting the data, processing it and making it available. While batch, you don't necessarily need to be getting it in real time. You can, it's in chunk, you ingest in chunk, that's the word. So you ingest in chunk, that's batch. So moving on, so data ingestion, I've explained this, storage and processing, transformation and modeling. Then data observability is just about the infrastructure you put in place to kind of monitor your pipeline, the monitoring and logging of your activities of your pipeline. So you want to know when it's being scheduled, when error happens, you want to be able to monitor it, you want to be able to do retries and all those stuff. Where data discovery is essentially knowing the kind of data that is in your pipeline. Then you have the endpoint where you have BI, whether it's BI, business intelligence or analytics. You want to do a machine learning activities, or just you want to have a data product that you can now sell or make available for people to purchase. Some organization does that. They don't necessarily do reporting. They just gather the data, make data available. Then they sell the data for those that will use the data for whatever things they want to use it for. Yeah, so to also drive this home. So this, the only thing I'll just explain here is to just tell you that sometimes the destination, we can have double destination, whereby you get the data from a source, you do whatever you want to do, then you load into a data warehouse. Then you can also have something aside from the data warehouse where you also need to load it to. So I'll start from the left as well. So you have your data sources. So from there, you load. So this is like you extract and load into a data lake. Then you ingest a data warehouse. Okay, fine. Let me just explain the difference now, so we understand. So a data lake and data warehouse are simply, they are both used for storage of data. They are both storage of data, but the difference essentially is that a data lake can handle different formats of data: structured data, unstructured data, semi-structured data. A data lake is aimed to ingest data in different formats, while by a data warehouse is usually optimized for read and analysis, and usually it's it's able to handle structured data. So that's like the main distinction between data lake and data warehouse. So in most cases whereby you are doing an ELT, so what happens is you extract from your whatever data source, then you load it into a data lake in the format, in the raw form, whether it's a structured format, unstructured format, whatever format it is, and whatever the way it is, you ingest it, you extract and load it to a data lake. Then from there, you transform or you load again to the data warehouse, and in the data warehouse, begin to perform your transformation or whatever you need to do. So what is happening here is we've extract and load into a data lake. Then now we are ingesting into the data warehouse. So remember the distinction. This one can handle different formats, and you can load your raw data into this. So, and it's also optimized. Another thing important distinction of a data lake is it's optimized for high storage. So you can handle large amount of data. It's optimized for that. Mobile websites can also handle large amount of data, but data lake is able to handle data with less cost. So from there, you can then, from your data warehouse, you can have another data warehouse. In this case, it will now be a data mart. So now a data mart is a data warehouse for a specific domain. Now, let me explain. So data lake to data warehouse is like, let's say you have an organization data in your data warehouse. So the data warehouse comprises of your finance data, comprises of your HR data, comprises of your customer data, comprises of your products data. Every other data you have in your organization is on your data warehouse. But then you now have a dedicated data warehouse now, a dedicated storage for, let's say, finance, whereby you want to perform anything finance, analytics, or finance, or anything finance, you go to that data warehouse. You don't essentially need to come to the central storage for the organization. So you have a specific storage for finance. So this is called a data mart. So it's a data warehouse that is specific for a particular data domain. So you can see have this as another level of data storage, or you can just directly have visualization or machine learning models or whatever use case you want to use it for. So these are the fundamentals of data pipeline design in layman's time, in beginner's level detail. And I hope it's clear. You still have time for question after this. So without further ado, let me just move on so that we maximize our time. So yeah. So now moving to the best practices after understanding what data pipeline is, the component of data pipeline, why it is important, design a good data pipeline. So now I'll move to the best practice of data pipeline. Now, the top of my list is to have a good domain knowledge. I may be biased with it because I'm an evangelist of having good domain knowledge. Last year now? Okay, now last 2 years now, I gave a presentation on this on Data First Africa 2022 about how important it is to have a good domain knowledge and how this can distinguish you between every other data engineer or every other data professional. It is so much important that you have to be intentional about it. And let me just tell you, there is this popular saying that I mentioned then that is still popular and is still relevant, is that knowing how to derive insights is not as important as knowing what insight to derive. So it's the same thing to pipeline. Knowing how to design pipeline, you can know everything about pipeline. You can use every tools, use Made, use Airflow, use Preferred, use Airbyte, use everything. You know GCP, AWS, Azure, you can do everything. But it is not as important as knowing what pipeline to derive. What do you want to design? Yes, you know how to do it, but what do you want to do? So that's where domain knowledge comes in. And this is like a very important thing that can give you an edge. So if you're working in any domain, maybe you are in the financial sector, manufacturing sector, agricultural sector, make sure you are interested in that domain to gain the knowledge of that domain, because it will really help you in your overall practice as a data engineer, from data pipeline to design to knowing the right question to ask, to interacting with stakeholders. Data engineers interact with stakeholders a lot because you have to communicate, you have to do data discovery, you have to know what the customer wants, you have to know what your stakeholders are expecting. So having a good domain knowledge helps you. And this is both hard skill and soft skill, because imagine you are in a meeting, you are the experts, and they are saying stuff, but you cannot relate. You don't know what it means they are trying to tell you in that meeting. How do you then provide solution to their problem? Remember, you are first a problem solver before even a data engineer. you are a problem solver, a data engineer. If there are no problems in the organization or in any way you are working, there is no point of you being in the organization. So you need to understand, speak their language, speak the language of that domain. So this is a very important, I put it as part of best practice because I know some people just tend to forget about it and just focus on technical. Yes, technical is good, but yes, you need to understand where you work as well. It's very important, and I can tell you, if you are very good with domain knowledge, it will really ease a lot of things. You even be able to, you'll be creative, you'll be innovative because you understand what you are doing. You can't be creative when you don't know the domain you are working in. How do you know the pain points? How do you know the problems they have? Aside from, you don't want to just be doing, they ask you to do A, then you do A. How do you know how to do from A to B if you don't know the domain, you have the domain knowledge? So that's very important. Now, moving on, having define clear objectives. Before you begin designing a pipeline, see a pipeline design as a project. Now, I'm going to be talking in high level because I know that best practices can be relative in terms of the team you work in, you influence the kind of best practices you employ. The organization we work with, we influence the kind of best practices you employ. The tools you use will influence the kind of best practices you employ. The technologies you use will also influence the kind of best practices you employ. So I'm going to be talking high level. I'm not going to be talking about best practices of Python, best practices of Airflow. I'm going to be talking. I've made sure I've designed in such a way that it cuts across everywhere in high level. So you can kind of now break this down to kind of apply it to whatever tools, whatever technologies you are using, because I know it can be so relative. As simple as naming convention is, if you are saying you have a best practice for naming convention, then you go to another team, then the team is saying, no, we don't use this naming convention. We use lowercase for our database objects. We don't use uppercase. You go to another where they tell you use uppercase or they use camel case or whatever. So it's relative. So, but at high level, these are very important. You need to define clear objectives. You need to treat your data pipeline as a project. And when you are planning a project, you have to have a clear objective of what problem is this pipeline going to solve. It's very important. What problem? So you need to understand. You need to understand your stakeholders, who are the important people that are using this pipeline. What is the end use of this pipeline? Is it going to be for a machine learning model? Is it going to be for analytics, or is it just going to be for to serve as data product? So this influence your decision on building the pipeline, how you make the data available at the end of the day. So you need to define the objective. You need to be clear at the onset. You need to ask questions. Very important. Ask questions. You need to ask questions. So this is very important. Then moving on, you need to clearly define and understand your data sources. So you need to know, what are my data, where are my data sources? Is it going to be in form of API? Is it going to be in form of transactional database? Is it going to be in terms of structure? Is it structured data? Is it semi-structured data? Is it unstructured? You need to understand the data source. You need to do data discovery to know, okay, fine, this data source, where is it coming from? Then when you do that, you also need to understand, how is this data being generated? Because trust me, you can't build a pipeline without fully understanding your data source, because your data source is the input to your data pipeline. So, and when your input is flawed, then there is no way you can get a very good output. It's just like garbage in, garbage out. So if the garbage in, if you don't take time to understand the garbage in, then be expecting a garbage out that corresponds to your garbage in. So you need to understand your data source. It is very important. It's a very important data pipeline design best practice. Know the structure, know how it's been updated, know in terms of, if it's going to be in terms of from a database, for example, you need to know what kind of operation happens in my data source. Let's say, for example, a table. You want to build a pipeline that moves data from a table to your warehouse, for example. So you need to understand what type of operation happens on this table. Is it just insert? That means, does the table, is it just append operation that happens on this table? So if it's only append operation, you already know, you can use that to factor how you're going to build your pipeline to sustain or to be robust in order to accommodate for just insert. You need to understand, is it does it support upstart, or is it insert, update, delete? All the three operations, is it happening on the table? Imagine a table having insert, delete operation, insert, delete, update operation on happening on it. It means you can't just use the same format you use to design a pipeline that ingests from a table that only has insert, which is not append. So in this case, you need to factor in the insert that happens on the source table, the upsert that happens on the source table, the delete operation that happens on the source table to build your pipeline to accommodate those operations. So this aspect, you want to spend time on this aspect to understand your data source. It is the difference between building an efficient pipeline and not building an efficient pipeline. Ensure quality data at entry. So you want to ensure your data is of quality at entry. You need to build validation checks on this. So you don't want to ingest flawed data into your pipeline. It is better you build this quality at entry so that you can manage any risk at the earlier stage rather than propagating through your pipeline and discovering at the later stage. So at that point, it becomes complex and it becomes a bigger risk for you. But if you ensure quality at entry, and that talks back to you understand your data source, you can build your quality at entry so that when you ingest data, you put validation rules in place to kind of, in terms of making sure there are no nodes, there are no duplicates entering your data pipeline, making sure their schema fits, and every other thing you can do to ensure data quality at entry. So these are pitfalls that myself I've seen people going through this in terms of not building data quality checks at entry and waiting for the transformation on the transformation layer, or maybe at a later stage before they can now validate and start building data quality entry. You need to start early, as early as possible. So it's just like raising a child. You don't want to wait for that child to grow up before you start giving that child morals and cultures and everything you want to learn. You need to start from the beginning. So it is very important. Then prioritize scalability. When you are building a pipeline, don't build a pipeline for now. Build a pipeline that scale, a pipeline that supports tomorrow's demand. And this is very important. And these simple things are like the difference between a senior and a junior and intern data engineer, because data is growing every day. No matter how small the organization is, data is growing every day, and you don't want to build a pipeline today and by next month or by next year, you're already going back to that pipeline. The time you are supposed to use for something productive, you're already going back to it to be thinking about how to scale it. What do you need to do? So you need to prioritize scalability. So when you are designing a pipeline, it is the best practice that you design a pipeline with scalability in mind. So I'll give you a very brief story. So there is this organization, it's a consulting organization, right? And they work with a financial institution. So at the point of consulting for this financial institution, and at the point of building them a data infrastructure to kind of help them derive insight in terms of performance and every other thing. So at that point, when they were building the pipeline, it supports the needs. The pipeline is functioning very well, it's producing value. But the problem is scalability was not put into consideration. And scalability is not just about one component of your data pipeline. It cuts across everywhere. So it cuts across your infrastructure in terms of your storage, in terms of your compute, everything you put in place. So at that point, the pipeline was designed, it was fine, running fine. I mean, the data quality is fine, but the scalability was not built in the pipeline. So after some years, it happens that a report or a process that used to take 1 hour to deliver from end to end, to run end to end, started taking 6 hours or more. And sometimes it is not about just making data available. It is about making the data available at the right time, the time where it is useful. So let's say, for example, you want to make a decision now, or you want to every day, you need to make a decision every day to kind of know how many products you need to order from your supplier every day. And you need that data by 12 p.m. so that you can make the order by 1 p.m. So it means the data that you need needs to arrive by 12 p.m. If the data arrives at 2 p.m., even though the data is going to give you what you need to order, but it has gone beyond the time you need it, which is a very important factor. So the reports are getting delayed. Then it means because scalability will not be the place and the kind of infrastructure that have been used, it's not something that can scale horizontally. Now, what I mean by horizontal scaling is we have two types of scaling: horizontal scaling and vertical scaling. Horizontal scaling simply means distributed scaling, whereby you can have clusters of infrastructures. So rather than scaling up, whereby if you are on a server, for example, you need to add more RAMs to that server. It's just single server. You need to add more RAMs, more storage to that server. for you to scale. But horizontal scaling means you don't use one. It means you really add another compute in terms of maybe another node in your cluster to kind of scale to support your data processing needs. So at that point, the pipeline is not as if it's not fine because it's giving data, but it's not giving data at the right time that is expected. And this is because it's not scalable because the data is not being available as at when due. So it's come back to redesigning. So now they have to go back to redesign the pipeline and every other thing. So you don't want to be at that point. You want to be at the point whereby if you need to scale, you are able to you've built it in your pipeline and is able to scale as the demand grows. So moving on. So now another important best practice is deterministic, idempotent, and immutable. Now, this is very important. I mean, it's not just about pipeline. This is like the basic rules of some programming. Like it's important. So, and what it means is that if you have a pipeline, you want to have a pipeline that is deterministic. Idempotent simply means giving the same inputs, you are going to get the same outputs. So your pipeline, if you design a pipeline, it means if you run the pipeline 200 times, giving the same inputs, the pipeline should give the same output 200 times. You don't want to have a pipeline whereby you give it the same inputs 2 times and it's giving you this different output 2 times. That becomes a data issue. So imagine you are processing, your pipeline processes the data for yesterday, whereby you have a batch processing. The same data for yesterday, it processes that data today. And management have used that data, maybe through analytics, they have used that data to kind of make decisions in meetings. And maybe for whatever reason, you need to rerun the pipeline. Then you run the pipeline is now giving a different output. Maybe initially, from the output of your pipeline, saying the revenue is 1 billion. By the time the pipeline is being rerun, the pipeline is saying it's just 500 million. So you want a pipeline that is deterministic, giving the same input, give the same output. It must be deterministic and determined, it's mutable. That means it doesn't change. It's reliable. Let me put it that way. So, and a very good example to drive this home is, I'll go back to water again. You can say I like water so much. So in fact, I'll even drink water now. Excuse me, please. So a good example is, imagine yourself as a pipeline. Now imagine me as a data engineer. So which means I want to design you. Now I now design you, giving you instruction that I have a glass of water. Then I tell you, add water to this glass of water. Now, I've configured you as a pipeline, and I've given you instruction as a pipeline to add water to my glass of water, to my glass cup rather. So with that instruction, it means you keep adding water. If I run you multiple times, you keep adding water, and it gets to a point whereby the water will spill off, right? So in that case, that is not you are not idempotent, because at some point, rather than adding water to my glass, the water spill off, and water now is going into the ground. So now imagine, instead of doing that, I now configure give you instruction as a pipeline to say, fill this glass of water until full, then do nothing. That is an idempotent instruction. That means you are now idempotent, because it means anytime I run you, you are going to fill this glass of water and fill no more, which means there is no spillage, and at every point of time, I'm going to have a glass full of water. So that's the difference between idempotent pipeline and a pipeline that is not idempotent. It means at every point in time, it's able to give you the desired results, giving the same inputs. This is very important in pipeline building, and sometimes if a pipeline is not idempotent, that's when you have duplicates in your pipeline. That's when you have data loss in your pipeline. So you need to be very careful and make sure your pipeline is idempotent, is deterministic, and is immutable. Now, use version control for development and collaboration. So what this means is that if your infrastructure or your technology allows you, because I know some infrastructure will not allow you to use version control end to end, but it is a best practice. This is why we are discussing best practice, to use version control for development and collaboration. See data pipeline design as software engineering, whereby you have to, track versions, you have to collaborate with code and every other thing. And don't do version control on your PC. I know some of us have been there before. Some of us might even be there now, whereby you track your code on your local PC. Then let's say you are designing a data pipeline for the data engineering community. Then you have data engineering community pipeline. Then maybe you do another modification. Let's say you add another table to ingest into the data pipeline. Then you have data engineering community final. Then you add another thing to it, or you supply another thing to it. Then you have data engineering community pipeline final. So don't do that kind of version control. Use tools that is for version control. Use Git, GitLab, or any other tool that is used for version control to manage, track your code, your development, and your collaboration. This is really important because it helps you to track your version, and it keeps your code secure as well. Imagine you are developing something on your PC, and for whatever reason your laptop crash. It means everything you have been working. Let's say you have been working on something for 1 month, and you have not pushed it to a version control system whereby you can go back and doing a git pull, you can get back your code back. So you have everything on PC and your PC crash, it is gone. Then you cannot collaborate, you cannot build together with a team because it means everything sits within your PC, right? So you need to imbibe the culture of using version control. I know some drag and drop may not allow you to be able to do version control, but wherever you can use version control for development and collaboration, it's the best practice to version control. When you leave an organization, it's always there. And what the important thing about version control is it also enables you to do CI/CD, which means continuous integration and continuous deployment. It means you can move from you can easily deploy your code. Now, choose the right processing paradigm. So this is about choosing whether you are going to be doing batch processing or stream processing. You don't want to do stream processing for a case study whereby you just need a batch processing. You need to understand this processing paradigm. So you don't just do stream because you've been hearing something about stream, and you just want to do stream. No, you need to understand what the requirement is, what the workload is, to know the kind of processing paradigm you need to choose. No matter how robust your pipeline is, if you are not using the right paradigm, then it's not efficient. So you need to understand when am I to use batch processing, when am I to use stream processing? Should my pipeline be ETL? Should my pipeline be ALT? Should my pipeline be just EL? You need to understand all these processing paradigms, and you need to choose the right one. So an efficient data pipeline is a right pipeline that is using a right processing paradigm. So you need to understand this. Then another thing is you don't want to because you know how to use a lot of tools, then you want to build a pipeline, you want to use all the tools. No, you need to use the right tools for the right problem. Now, DRY, which is don't repeat yourself. So what this simply means is that you need to build your pipeline in such a way that you can reuse the component of your pipeline. You can have different components in your pipeline, whereby maybe for cleaning task, you develop it as a component so that you are building another pipeline later. You're able to use that component in your pipeline. You don't have to necessarily restart afresh, design your pipeline. So don't repeat yourself. It's a very important coding principle, and it's also applied to data pipeline. Don't repeat yourself. Build once, use multiple times, use later. Build in templates. So that means it makes your development faster. If you are developing a pipeline for the first time, you use dry method. It means you can reuse, even in your pipeline, you can have a case whereby you need different functions at different points in your pipeline. So you don't want to start coding or start developing different at different time you need it. So develop once, you can then import and use it at every other point you need in your pipeline, or you can even reuse it in your new pipeline you are building. So don't repeat yourself. Prioritize incremental data ingestion. So this is very important. So incremental data ingestion simply means ingesting the difference between the last ingested data and the new ingested data, and the current time rather. So it means if you have 1,000 records in your base table, and maybe after some time it's increased to 1,100 records, you don't want to ingest 1,100 record because you already ingested 1,000 record initially. So it means you only want to ingest the difference between 1,000 and 1,100, which is 100. So this makes your pipeline performance in terms of being fast, in terms of being optimized, and it also reduces cost. So it means you are not computing 1,100 records, you're only computing the incremental load. So use this when it is applicable. So incremental data ingestion is the difference between sometimes between a pipeline that is efficient and one that is not efficient. So you want to make sure that you maximize this approach as much as you can. Incremental data ingestion is the way to go. So you only ingest what is needed. So you can do base load. For the first time you are running your pipeline, you do base load. Then every other time you are doing it, you are doing incremental load. So you don't necessarily need to ingest the full snapshot of your source data every time. So prioritize incremental data ingestion when building your pipeline. So keys. So pipeline should be optimized against cost. So keeps is just keep it simple, stupid. So it's another coding practices is also applicable to data pipeline. So you want to make sure your pipeline is as simple as possible. Don't make your there is no gain, there is no benefit in making your pipeline complex. You don't put rockstar and build pipeline that is complex and say because you can able to use in your pipeline. I've used Apache Spark, I've used Hadoop, I've used everything. Now my pipeline. That is don't be carried away by want to using every tool or every technology. No, in fact, there's senior data engineers or senior professionals. They know how to build complex solution, provide complex solution to problems using simple tools and technologies. And yes, the advantage of this is it becomes really easy to maintain. You don't want to build a pipeline that when you are not there, nobody is able to maintain it. Let's say, for example, you go on leave or anything, then nobody is able to pick up whatever pipeline you built and able to maintain. Maybe there is an issue, they need to really fix it. You don't want to do that. So keep it simple, stupid. Don't develop something complex. Don't say for example, you have an Excel file that needs to be ingested into a table in your data warehouse. Don't say you want to go and spring up a composer environment or you want to spin up an Hadoop cluster just to ingest a flat file because you know how to use it. No. Something that you can do with just cloud functions and you'll be fine and good. So design modular and automated pipeline. So make sure your pipeline are modular so that every bit is designed in such a way that they come together to form your entire pipeline. And if there is an issue with a particular module, you don't necessarily need to redesign everything or to break out everything. You just need to work on the module that is having issue, or you want to add a new feature. So you just add the feature to the module, then everything comes back together to work together to give you the desired output. Automated pipeline, automate your pipeline. So a pipeline that is not automated, to me, it's not a pipeline. So because the essence of having a pipeline is to make sure that it's automated so that you get your data in the schedule interval you've configured without any manual intervention. So a pipeline should be automated end to end. So a data pipeline that you need to go and do some things manually is not an efficient and scalable pipeline. It must be automated end to end for you to say you have an efficient and scalable pipeline. It's a best practice for your pipeline to be automated end to end, and just not just automated, it must be automated end to end, which means from source to destination, it must be automated without manual intervention. Right? So going forward, appropriate testing, exception handling, and logging. So you want to make sure that you are building validation checks, assertions, testing, exception handling. When your pipeline is encounter an issue, maybe you need to retry or something, then logging. So you want to make sure you have maybe watermark table or something whereby you log your metadata of the pipeline metadata in terms of the time the pipeline runs, how many minutes the pipeline runs for, in terms of how many the size of compute the pipeline has taken. So you want to log it so that for monitoring, for maintenance, you want to log it. You want to make sure you are logging your data pipeline operations. You want to make sure you build test rules in your pipeline so that every stage in your pipeline, from extraction to transformation to loading, you are building tests to test your pipeline to make sure it fits. So that at the end of the day, you are getting quality data. Because remember, you don't want to build a pipeline that is causing confusion rather than giving insights. So you need to make sure at the end of the day, the data that you are giving out in the pipeline is tested and fit for use. Prioritize data security and compliance. So you need to ensure that you build security rules in your pipeline. You don't expose your secret keys. You don't expose PII information. Your pipeline is compliant in terms of building rules in your pipeline that surrounds privacies and every other thing that needs to be taken care of. So these are important best practices in building a pipeline. Implement robust documentation. So you want to make sure that you have a robust documentation of your pipeline. Have your high-level architecture diagram, your low-level architecture diagram. Make sure you have your ERD, have your data catalog. In fact, anything that is useful to your pipeline, document it, because you may not be there forever. And even if you are there forever, you won't be on that project forever. And when you come back to that project, trust me, human being, we are as recent as when we are doing things. When you come back to it, it becomes alien to us. So if you work on a project this month, by the time you do 2 other projects, then you come back to that project maybe after 3 months, then we begin to struggle. How do I do this? What does it get? So, but when you have the documentation in place, you can pick up the documentation. Anybody can pick it up. Then you can understand what you have done. You can know where all the parts of your data pipeline, you can know where they are, and everything in terms of maintenance, in terms of adding features to it, can be easily done. No matter how robust, no matter how scalable, no matter how efficient your pipeline is, if your pipeline does not have robust documentation, it is not a good pipeline, because documentation is the heart of the pipeline. It needs to be concise. You need to have a comprehensive documentation of your pipeline. It is very important, and I think that's why I put it last. It is very important. You need to document it. It's a practice you need to kind of incorporate into our pipeline. And most importantly, don't always have in the back of your mind that when you are building data pipeline, optimize your pipeline against costs. I've heard many people mention that they want to build first and think about cost later, so that they can focus on building and later think about how they can minimize costs. No, you have to start. When you're starting, you have to start building cost optimization into your pipeline. You don't want to finish and come back to cost optimization, because cost itself as a thing, it can influence how your pipeline is going to be. It can influence the infrastructure you are going to make use of, the tools and technology you are going to make use of. It is very important to start building costs, factoring costs into your pipeline from the initial stage. What is the point of having a pipeline that is not cost effective? Because at the end of the day, let's say you are building a pipeline that supports a business case whereby they want to target more customer, or they want to make more profits. The organization wants to make more profits, and your pipeline itself is already costing them more than the profit they are even expecting from the insight your pipeline is giving. Then where is the value? Where is the solution you are providing to the problem? So you want to ensure that as much as you can, your pipeline is optimized so that it can be cost efficient. And remember, already as a data engineer, you are a cost center to the organization. No matter how so innovative, no matter how creative you are, no matter the solution you are bringing, you are a cost center to the organization. Most organizations, IT team, they are cost center. So you're already incurring costs for the organization. They are paying you. You are using resources they are paying for, and with the rise of modern data engineering in terms of cloud and everything, cloud can make it so easy for you that you have the resources. In fact, it's like you are in Atlantic Ocean. So resources is just there, serverless. You don't even need to manage it. You don't need to manage it. You don't need to bother about how it's been provisioned. Just be using it. And if your care is not taken, you just use what you don't even need. And no matter what it is, you are going to pay for it. And you want to be efficient, so that when you build a pipeline, it's cost minimal, so that they can get maximum value for whatever solution you are providing. Not that, oh, this pipeline is good, we are able to get this data at the right time, the data is robust enough, but the problem is it's costing us too much. Then they start thinking about replacing substitutes. If the value is there, but it's costing us too much, what's the essence? Your cost is already. So it's not even about reducing cost, it's about optimizing cost. Make sure that you are putting costs in place in terms of building your data pipeline. It is very important. And I hope I've spent more than an hour already. So I think you can have questions now. So I'll be stopping there. So I hope I've been able to explain. I hope I've been able to dissect in terms of designing data pipeline, the high level best practices you need to put in place when designing a data pipeline. I hope for the beginners, they